Hello and welcome to the Cyber1 YouTube channel. My name is Ray, and in this video we are starting our journey into speech services. Speech services are complex. There's quite a number of options. And so we will start looking at the text-to-speech services. Okay, so one of the first things we're going to do as we start to execute our speech.py is load in the config file. There's people following this channel and following this series will actually recognize this as our call to the config file. So let's go and have a look at our speech config file. Speech services can be divided into two categories in broad terms. There is the text-to-speech where the robot is talking, and then there is speech-to-text where the robot is listening. So we're going to look at first the text-to-speech. Now there are a lot of different text-to-speech engines available out on the internet that will run on a variety of different operating systems. There is a built-in speech API in the Windows operating system, which you can access with the tts.exe file that is supplied with MyRobotLab when you install it. On the Mac, they have the program Say, which is available by default. So you can say, at a terminal window, you can type say space quote the text you want to speak, quote, press enter, and it will speak it out. Very similar to the tts.exe for Windows. In the Raspberry Pi, if you've got a standard install of Buster rather than the full desktop, it may not necessarily have any text-to-speech engines installed, but there's a huge variety from which to choose from that you can install. Some are easier to install than others. eSpeak is actually very easy, so is Festival. The default for MyRobotLab on Linux was Festival, still is, but before we can use it we need to install it. So we're actually going to touch on that as well. The default text-to-speech engine for MyRobotLab across all platforms, however, is Merry Speech. By default I've actually got it set to true. You can, however, set it to false and choose one of the others. Now this is where it's important to note you can or you should only run one text-to-speech engine at a time. You can only link the output of the program AB to a single text-to-speech engine, so you're better off only running one at a time. In this case, the default is Merry Speech, but what we can do is change either Mimic Speech or eSpeak or Local Speech to being true, but when you set one of those to true you must use Merry Speech to false. You can only have one of these set at a time, and this may in the future be changed to be select by number so that it forces you to only have one. If you do leave Merry Speech set to true, I do have some sanity check code in the speech.py that will disable the others. So it will work its way through the list. The first one is set true, any others selected will be set back to false as at runtime, not in the configuration file. So just keep in mind you can only have one at a time. Going through the config file, we also have the two speech-to-text services. Now a little bit of a warning on Sphinx. Sphinx runs local, does not use the internet. However, it is depreciated. There is a new speech-to-text service being implemented in MyRobotLab. It is not yet ready at the time of recording. I will code at the time when it does become available to use it, but for now the only one available is Sphinx. The documentation for it is very light on at the moment because it is being depreciated. WebKit speech recognition service actually uses the Google AI engine in the cloud to convert your spoken text or spoken speech into text. It is a very broad engine in as much as it will interpret quite a range of phrases into text. It's not limited by the words like Sphinx is. Sphinx will only interpret words that you have predefined. So if you have a set of commands that you need to execute, you can predefine those commands in Sphinx and it will then interpret those words. A lot of the very early Inmoov videos that you'll find from Gael was using the Sphinx engine. But later they went to the WebKit because it is actually a better engine. The downside of WebKit is it does require an active internet connection for it to work. If you don't have an active internet connection, it simply does not work. Okay, now we've been over the configuration. Let's have a look at the rest of the program. After we run the config, we do our sanity check to make sure that we're not doing anything silly, and we will make sure everything else is set to false. So we can only have one at a time. In this case, this one defaults to using Sphinx. With this bit of code, let me highlight it. So that one defaults to using Sphinx, whereas this one will default to using Merry Speech. The other one is, while eSpeak is available for Windows, there's a little bit more involved in getting it installed. I haven't explored it far enough to be able to give you instructions yet, but if I do, I'll add it into the documentation or the comments on how to set it up. All right, let's move on to the next part. So Merry Speech is the most common one used. It is the one used by default in the Inmoov services. If you're running a Raspberry Pi or Linux, don't forget to make note of this little section where you need to basically take pulse audio out of the equation. It does stop speech coming out where you expect it to come out. So like most services here, when we fire them up, Merry Speech comes with MyRobotLab, so it is working on all operating systems out of the box. It is easy to set up, and you can change the voice that you're using, but it can be a convoluted way of setting up the name. And there are ways of experimenting to determine what voices are available. There is a command, and I can't remember it off the top of my head, something along the lines of get voices, and it will give you a list of the voices. I think there's get voice, which will show you the currently selected voice, and get voices, which will give you a list of all the voices. And we'll look into that a bit later on as well. That allows you to change which voice you're running. Okay, so in Windows, Mimic Speech is supplied, pre-installed. It comes as an executable, and it's in the MyRobotLab directory. This section of the program will actually work out, are you running Windows or are you running Linux or Mac? And if you're running Windows, it will launch the Mimic Speech. If you use Mimic Speech and the platform is Windows or it's Manticore. Back in Manticore, you could change the path to the Mimic Speech executable, and that allowed you to choose a different path. So if you're running Linux and you wanted to run Mimic Speech, you could install Mimic Speech and then you set the path to the executable and all worked well. But when they changed to Nixie, for some reason they took that out, and that meant that you could no longer use Mimic Speech on Linux. This was later changed so that you could use it through the local speech, and I'll come to that shortly. So if platform is Linux and you get this far in, then this is where we change the path, and this is the path where Mimic Speech is installed by default. Now there is on the GitHub a set of instructions on how to install Mimic Speech on the Raspberry Pi. It should be very similar for the Mac. This allows us to set the path. It also prints the voices. This isn't really necessary in the code. We can actually comment that out. This is one that you would more likely print at the Python window within MyRobotLab to find out what voices are available. We set the voice that we want. Again, it's all coded, and then set the volume. Alright, so for all other speech engines, we're using the local speech engine. But before you can use those, you need to make sure you've got the local speech services you're planning on using installed. So in the case of local speech, you would need to make sure you have Festival installed. And there's your command to install Festival on a Raspberry Pi. It should work also on the Mac. The default for Windows is to use tts.exe, which is supplied as part of MyRobotLab. Okay, so if you want to use eSpeak, this is the command you need to execute. And that'll install eSpeak. So eSpeak and Festival are very easy to install. They are packages that are pre-compiled, ready to install on the Raspberry Pi. And as far as I'm aware, they are also available for the Mac. For those who are not familiar with the Mac, the back end of the Macintosh is actually Linux. The apt-get, there is a slight variation there on the Mac, and because I don't run Macs, I couldn't tell you off the top of my head what that one is. But if you're familiar with using a Macintosh, you'll probably learn that one pretty quickly. If you're running into trouble with it, post a question in the Discord. There are a couple of Mac users who will be able to answer that. Okay, so the code's pretty simple. We start local speech, and in this case we're calling it mouth. All of the speech services or text-to-speech services we're calling mouth. They are all accessed the same way within MyRobotLab, so this makes it a bit easier to, if we have them all the same, it doesn't matter which one we've got, it's easy to access in the rest of the code, and it gives us all the flexibility we could want. Right, so if we're not actually using local speech, so if we're using, say, eSpeak, we need to change the path. Now this is new for local speech within MyRobotLab, and this is one of the reasons this video was delayed being developed, is because all of this was in flux. It was all being changed to make it more flexible, and this will result eventually in Mimic Speech being removed altogether from MyRobotLab as a independent service, as it's brought into the local speech. So we will be able to literally call on any text-to-speech engine that comes out in the future by simply setting the path and then setting the command string. So this is the path to eSpeak, and for a Linux-based system, and this is the command string that we need to use to run it. So let's go through the command string a little bit more, because if you're adding a different text-to-speech engine, this is where you would add it. So you've installed your new text-to-speech engine. It works well from the command line. There is a path to it, and you will need to set the path for the text-to-speech engine. you then need to set the command. Now the command is what we call a template. And this is how MyRobotLab is to pass the command to the text-to-speech engine so that it understands it. The key things that we need to be able to send through to that text-to-speech engine are the text to be spoken, and we need it to save it out as a sound file. It's not going to send it directly to the speakers immediately. It's going to send it out as a sound file because there is interaction between the speech service and the servo services, potentially with mouth control. So we need it to return with the sound, and then we can coordinate the servo control of the mouth with the speech. So in the case of this example, we're using eSpeak. So the command is eSpeak. Now, for those who are not familiar with that little feature, this is what's called escaping. So we escape the quotation marks because in the command line we need to put what we speak inside quotes. Everything between the curly braces here and the word text will be removed. The curly braces and the word text will be removed and replaced by whatever the program is telling it to say. So the program might be saying, hello, I can really hear the smile in your voice, which is a standard return from the program AB. It will put that inside quotes. The -W is the command to save the audio to a file, and the curly brace file name is actually the name of the path that the file will be saved to, and that is defined by the MyRobotLab program at runtime and is quite often different for each phrase that is spoken. Now, something I did learn last week was it will quite often recycle phrases. So if it has already spoken a phrase, it will pull that out of its cache and speak it again without having to run it through the speech processor or the speech engine. Now the next one is voice. So in eSpeak, -V and then the name of the voice. So there is default voices configured within MyRobotLab, and it will populate that voice with the default voice. You can use the commands get voices to get a list of the voices and set voice to set the voice name, which we've done down further. So different speech engines have different way or different command sets. For example, in the next one where we use mimic speech, we use mimic -T the text. So in eSpeak there is no -T, and the file name is preceded by the -O instead of -W, -O being output. So this can vary for all the different speech engines, and you just need to make sure this command template file, TTS command, is correct for your speech engine. So you can use other speech engines that are not listed here. You can add them in. Alright, we get the list of voices from the speech engine, and then we can set the voice that we want to use. We set the volume, and the program will then call on it whenever we need to call on it. Okay, when it comes to speech to text, which is the other way around, we have Sphinx and we have WebKit. So Sphinx I haven't gone into with a great deal of detail, mostly because the documentation is no longer available, with it being depreciated or not readily available. But yeah, we add in the list of words that we're going to be using. And like any other speech to text engine, whenever it receives text of words or a string of words that it understands, it will publish that list of words. In this case, we will be publishing it to program AB. That link is done at a later part of the program, and I will get to that shortly. WebKit speech recognition, being the Google one, does require an internet connection. One of the options we have is to start the graphical user interface right back at the beginning of the system. By default, I think I do start it at the graphical user interface. I do start, but I don't start or don't launch a browser. If we haven't started it, so if it wasn't started at the beginning of the system, we need to start it, and so we start it now. We disable the auto start, we'll start it manually a little bit later, and then we start the service. We create WebKit speech recognition, and we're going to call it ear. So all of our speech to text recognition we'll call ear, because that's what we listen with. Once it's up and running, then we can start our browser. We can also program a wake word, and if you haven't set one back in the speech configuration, it will actually take the robot's name as defined in the original system setup and use that as the wake word. Auto listen is handy, but it can also be a pain in the ass at the same time. So if you have auto listen set to false, the robot will eventually put the speech recognition to sleep and it won't hear you. You can even use the wake word and it won't hear you. Or at least that's my understanding of it. It's still something I need to experiment with. In any case, it will keep listening. Now that can lead to some interesting results with it picking up on words that weren't actually being spoken to it or from other systems. And there have been conversations that have gone on strangely between two robots as a result of that being set to true. Set continuous false. Now I believe that's the one where it will actually put the ear to sleep but still listen for the wake word. Set wake word is only available in Nixie. It's not supported by Manticore at all, so this is where we actually set it. If we're using Sphinx or WebKit and we're using one of the predefined speech text-to-speech engines, we will attach the mouth to the ear. So when it's speaking, it will stop listening. Okay, that basically covers the speech services at a broad level. We will use these speech services when we get to the brain, and we will link those to the brain, where we add the ear to the brain. The brain in this case is program AB, and there is a lot to cover in program AB. That may be split over multiple videos, because while this section of code is very simple, it just starts program AB. It starts a session called builder. It adds a text listener for the mouth. That's basically linking the output of the program AB to the text-to-speech engine. And down here we link the brain to the ear, or to the speech to text, we link to the brain. So as you talk to it, whatever you speak goes to program AB, and then program AB will output to the text-to-speech engine. So that's over 25 minutes, so I'll wrap this video up, and we will see you in the next video. In the next video, we might start looking at some of the life services, and then later on we'll come back and look at program AB. To see when that video comes out, don't forget to click on subscribe and ring that notification bell. If you like these videos, don't forget to click on the like button. I do have a Discord channel. That Discord channel will have a link in the description below. There are other like-minded people, and you can also ask questions directly in that Discord. If not myself, someone else will probably have the answers to help you get your project up and running. I also have a Patreon account for those who like to support this content, and you'll find a link in the description. I would like to thank at this point my Patreons who are helping to support this channel, and that would be Go Lucky and El Morales 45. Big thanks to those two. I am releasing videos currently 2 weeks ahead for Patreons, and we will see you in the next video.